Good afternoon, students. Welcome back to the session on data flow in MapReduce. So here in this slide, we are going to understand what are all the various components that are needed to do the MapReduce programming. So first, we understand what a MapReduce is. A MapReduce is a core component of the Hadoop that processes a huge amount of data in parallel by dividing the work into a set of independent tasks. MapReduce is a data processing layer of Hadoop. It is a software framework for easily writing applications that processes the vast amount of structured and unstructured data stored in the Hadoop distributed file system. It processes huge amount of data in parallel by dividing the job into a set of sub-jobs, which are nothing but the independent tasks. So here we see the diagram, the MapReduce job execution flow, which consists of the input files, the input formats, then we have the input splits, the record reader, then we have the mapper, then combiner, partitioner, followed by shuffling and sort stage, then we have the reducer, then we have the record writer, and finally the output format. So here in MapReduce, what is a MapReduce? We all know that it is nothing but processing huge amount of data, where the data is going to be stored on multiple nodes and the work is going to be executed parallelly. And this normally consists of two phases. One is the map phase and the reduce phase. The map is the first phase of processing where all the complex logic code is specified. And reduce is the second phase of processing where we specify lightweight processing like summarization or aggregation operations are done. So here are the list of various components of your MapReduce. Input files, input format, input splits, record reader, mapper, combiner, partitioner, shuffle and sorting, reducer, record writer, and output format. All these components are in sequence. So there is nothing that you can skip any of these components and go to the next, except for partitioner and combiner. They are little optional, but the remaining components are mandatory. So what is the input files? Normally the MapReduce task is to process huge amount of data. But where is the data residing? The data is normally stored in input files, and these input files typically live in Hadoop distributed file system. And the format of these files is completely arbitrary. It can be a line-based log files or it could be a binary format. And the input format defines how these input files are split and read. The input format normally creates input splits. It selects the files or other objects that are used for the input. What is an input split? It is a one that is created by the input format, and it is a logical representation of the data which will be processed by the mapper. And for every input split, there will be one individual mapper. So one map task is created for each input split. So thus, the number of map tasks will be equal to the number of the input splits. The split is divided into records, and each record will be processed by the mapper. What is a record reader? It communicates with the input splits in Hadoop MapReduce and converts the data into key value pairs suitable for mapper. Mapper cannot directly interact with the input splits. Mapper can only understand the data which is in the form of key value pairs. So the record reader, which is in between the mapper and the input splits, does the job for the mapper, creating a format that the mapper can understand, which is normally in the form of key value pairs. It uses the text input format by default for converting data into the key value pair. It communicates with the input split until the file is not completely read. It assigns the byte offset, which is a unique number, to each line present in the record, which will be denoted as the key, and the value will be the content of the line. Further, the key value pair are sent to the mapper for further processing. What is a mapper? It processes each input record that is received from the record reader and generates a new key value pairs. And this key value pair that is generated by the mapper is completely different from what has been generated by the record reader. We know that the record reader generates a key value pair, which is nothing but the byte offset, that is the starting position of the line, and next the value, which is the content of the line. But the mapper's output is completely different from the record reader. The mapper normally tokenizes the line and gives a count of 1 for each word it finds. And the output of the mapper is completely different from the record reader, and it varies from application to application. The output of the mapper is known as the intermediate data, which is written to the local disk. But the storing of this output into the local disk is purely temporary, because it may create unnecessary copies. The mapper's output is passed to the combiner for further processing. What is a combiner? A combiner is also known as a mini reducer or a semi-reducer. It performs local aggregation on the mapper's output, which helps to minimize the data transfer between the mapper and the reducer. Once the combiner's functionality is executed, the output is then passed to the partitioner for further processing. As there are number of mappers, so will be the number of combiners. What is a partitioner? A partitioner comes into picture only if you have more than one reducer. For one reducer, there is no need for a partition. Partitioner takes the output from the combiner and performs partitioning. It takes place on the basis of the key and then sorts it. By the hash function, by the hash function, the key is used to derive the partition. Every combiner's output is partitioned, and the record having the same key will go into the same partition, and then each partition is submitted to the reducer. Partition allows even distribution of the map output over the reducer. Otherwise, some of the reducers may be heavily loaded with the work, while the other reducers have little amount of work to do. This leads to what is known as a poor partitioner, which can be overcome by making use of a custom partitioner. The next stage is the shuffling and the sorting stage. The output is shuffled to the reducer stage. The shuffling is nothing but the physical movement of data over the network. Once the mapper are finished and their output is shuffled on the reducer nodes, then this intermediate output is merged and sorted, which is then provided as an input to the reducer phase. In a short way, we can understand shuffling always tries to collect all the values of a particular key, and then the sorting phase, when it's applied, sorts all the key value pairs based on the key in the ascending order. Reducer, it takes a set of intermediate key value pairs produced by the mapper as the output, and this output will be given as the input to the reducer, and the reducer function runs on them to generate a new key value pair. The output of the reducer is a final output which is stored in the HDFS. As we know that if the number of partitioners are 1, the reducer is also going to be 1. So the number of partitioners will be decided by the number of reducer tasks. If the reducer tasks are more than 1, then more than 1 partitioner is being created. And there will be 2 sets of outputs that are going to be generated from each reducer. But by default, we have only 1 reducer, so the output is going to be 1. Record writer. It writes these output key value pairs from the reducer phase to the output files. Output format. The way these output key value pairs are written in the files by the record writer is determined by the output format. Output format instances provided by the Hadoop are used to write files to HDFS on the local disks. The final output of the reducer is written on HDFS by the output format instances. So it is a way that specifies how the output is written in the files which are written by the record writer.